here we go. Domain is the x values. It is your input, and you want to think of going left to right on the graph, okay? Where does it start as you go from the left to the right? Okay, and then the range is your y values or the output, and you want to think of going down to up on the graph. So start at the bottom, go to the top. Where does it start as you rise along the y's? All right, so go ahead and write down f of x equals 5, g of x equals x, h of x equals negative x minus 2. So for this one, f of x just means y. That is the exact same thing. Y equals 5 is just the line of a graph that cuts through the y-axis at 5, okay? I like to think of the graphs. It does help, okay? So for your domain, how far left does it go? How far right does it go? Yeah, forever. So this one's just x is an element of the reals. It's everything. It's all the reals, okay? All the numbers to the left, all the numbers to the right. All right, but then for the range, the only y value is what? It's 5 the entire time. Y is just 5. That's it. That's all it is. It's 5, okay? All right, for this next one, g of x equals x. This really just means y equals x, okay? If you were to graph it, that's plus 0, right? The y-intercept 0. You're going up 1, right 1, up 1, right 1, up 1, right 1, and you would draw this lovely line. Everyone, what is the domain? Great job, everyone. It goes all the way left, all the way right, okay? It's slow, but it's going forever to the left, forever to the right. Okay, it's got arrows. It's going forever left, forever right. All right, how about the range, everyone? What is the range? Same Z's, exactly. Y is an element of the real. It's everything. It's going forever down and forever up, okay? All real numbers. A lot of lines are all real numbers, okay? This next one, h of x equals negative x minus 2 is just y equals negative x minus 2. I mean, I don't even know that you need to graph this one, okay? Maybe you do, maybe you don't. But it's a y-intercept of negative 2. You go down 1, right 1, down 1, right 1, down 1, right 1. Draw your line. What's domain? All real numbers yet again, okay? And how about the range? Same Z's, but with Y's, exactly. All right. Okay, you could also plug these into your calculator if you really wanted to. All right, you could go to the on button, go to home, and then go to graph, okay? And then you've got f of x, y equals, and I would plug in like negative x minus 2, the one I just did. And I could look at what the line looks like. All real numbers, okay? I like looking at the graphs, especially on some of the harder functions. All right, let's go back to this. All right, radical functions. Inside, the radical cannot be negative. Okay? Anytime it's a square rooty graph, you can't have negatives under the house. Okay? You can only have positives. So you set the inside greater than or equal to 0. That would mean always positive if it has to be greater than or equal to 0. Everything under the house has to be positive, okay? So, in other words, I take this little piece here, 9 minus x, and I set it greater than or equal to 0. It has to be positive. Sometimes I just think through. I know you can do both ways, okay? If you don't want to think, just do this. All right, greater than or equal to 0. Add the x to the other side. So 9 is greater than or equal to x. But then you have to flip the whole thing, right? If 9 is bigger than x, then x is less than 9. So you flip the whole thing around, okay? So what this means is anything below 9 works. Why is that? If I plug in 8, what do I get? Positive 1. If I plug in 7, positive 2. That's all good, okay? If I were to plug in, though, 10, what do I get? A negative number, and that's a problem, okay? So you can't have anything above 9. All right, and the way we write this domain, we say x is an element of the reals such that x is less than or equal to 9. I'm going to show you one graph, okay, of these just because I think it's cool. All right, menu, let me clear this one, delete all, yes, delete it, press the tab button, and I'm going to do the square root of, I already forgot what it forever up, okay? It starts at 0. Why is that? Well, if I plug in the domain, okay, I have to start at 9, okay? If I plug in 9, I get 0, okay? If I plug in 8, I get 1. So notice I'm getting 0, 1, 2, 3. I'm going to get like bigger and bigger numbers, okay? It's 0 and up, all right, for the range. But we're not going to do the range on these. Okay, for this next one, now I have x minus 9. Set what's underneath the radical greater than or equal to 0. Add the 9 over to the other side. So x has to be greater than or equal to 9. All right, so my domain would be x is an element of the reals such that it is greater than or equal to 9. That would give me all positives. So we'd be good to go. If I plug in 10, 10 minus 9 is 1, and I'm happy. If I plug in 11, 11 minus 1 is 2, and I'm happy. All right. Okay, and now let's do the last one. Take what is under, oh, yellow. I didn't know I did that. All right, take what is underneath the square root, set it greater than or equal to 0. Okay, subtract the 4 from both sides. So x has to be greater than or equal to -4. And then we write it, domain, x is an element of the reals such that x is greater than or equal to -4. Okay? And that would ensure I get all positives. Every single range will be greater than or equal to 0, by the way. We're not going to do the range, but they will all be y is greater than or equal to 0. Okay? All right. Now we have rational functions. This is the third one. This is the last one, you guys. What can I not have in the denominator? What is never allowed in the denominator of any fraction? Yep, I can't have 5 of nothing, okay? So the denominator can't be 0. This is one of those big math rules that never goes away. This is important in calculus, all right? This is like important for forever. You can never have 0 in the denominator of a fraction. So you set the denominator equal to 0 to figure out what would give you 0, or just look at it and be like, self, what gives me 0 in the denominator? Okay, what can x not be in this problem? 2. So I would be like, all right, domain, x is an element of the reals. It could be anything, except it cannot be 2, because that would give me 0. And for fun, I want to show you guys this graph. It's really cool, okay? 1 over x minus 2. So let me delete this one out. Okay, yes, delete. Press the tab. 1 divided by, I guess I'll put some parentheses in here. All right, x minus 2. Enter. Oh my goodness, how crazy. What is missing from this graph? 2, okay? There is what's called an asymptote as you get into older graphing math life, okay? But x can't be 2. It skips everything. It like goes real neat this way and real neat that way, but it doesn't have 2 in it, okay? So it's everything but 2. All right, so for this next one, we would say domain, x is an element of the real such that what can x not equal? 2, again, because 2 minus 2 would give you 0. All right, and this last one, if you can't do this in your head, you set it equal to 0 and you solve, okay? So you would add the 4 to the other side and you would divide by the 3, which means x cannot be 4/3. So we would do our domain, x is an element of the reals, but it can't be 4/3 because that will give you 0 in the denominator. Okay? All right. There's more. We're done. Okay, so now we have to do by just looking at the crazy graph, right? Any kind of crazy graph that they give you. Okay, so I would be like, all right, domain. And this one you do domain and range, okay? X is an element of the reals. However, it only goes from here to here. Where is that on the x-axis now that I just wrote on it and you can't read it? So it goes from where to where? Great job. It goes from -5 on the x-axis to 4. So you write it like this, where x is in between -5 and 4. You do the bars underneath because it's closed circle. Okay? Now we've got range. Range is y's, so y is an element of r such that. Now for range, you go start at the bottom, boop, 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 boop. Oh, where do you start? Yeah, -3 up to +3. Even if there's not whole dots, that is assumed that there are whole dots. We went from -3 to +3. Okay. Okay, let's do this one. What is the domain, you guys? Oh, I think that's actually -4. -4, okay? So -4 is less than x is less than or equal to 3, okay? And how about the range? What's the range on this one? -5 up to 2. All right, but -5 looks like this, and 2 has the line underneath. No line on those open circles. All right. Okay. Sorry, these are forever. All right, domain on this last one. It's forever. It's pointy. It's an arrow. All right, it's an arrow. So I've got x is an element of the real such that this goes from what over on the x-axis? 0. 0. So it actually is x is less than or equal to 0. Tricky. All right. And then your range, the y's, this is the last one. Okay. No whiteboard, stay there. All right. Range starts where? Starts at -3 and goes forever up. There's an arrow. So y is actually greater than or equal to -3 on that one. That was kind of a tricky one. There's a couple tricksters on this worksheet. All right. But we'll get through